Hi and welcome. I'm Philip. Let's dive into the next session. Let me share my screen. And while I'm getting there, here are my slides. Security code injections and logging is what I want to show you today. So OWASP 10 is probably a topic that you already have heard of. So it's a list of the most common security issues in web applications, ranging from something like injections in number 1 to number 10, logging. So let's see what we have here. Oftentimes, in terms of security, you say, well, this is kind of fine. Maybe my application or maybe this external application that we're running is okay-ish security-wise. And then you see all the issues around SQL injections that keep coming up again and again. And you realize that maybe things are not as fine as you would want them to be. And then you continue further down the list, and then you see at point 10, for example, insufficient logging and monitoring. You don't even know what is happening in your application. And then you realize, well, maybe nothing is fine in my application and everything is on fire and everything is terrible. And we kind of want to avoid this everything is terrible approach. So let's dive into how we can work around that a bit. I'm Philip, like I said. I work for Elastic as a developer advocate, so I mostly show interesting technology around our stack or other things in the general ecosystem. If you've never heard of Elastic, we do things like Elasticsearch, Kibana, Beats, Logstash. So we do a lot around collecting information, and we will dive into that here and there today. So I generally build Hello World applications. So those are probably simpler than what you will run into in the real world, but you will find a lot of pieces that you can reuse here. So while my problems are kind of simplified, and especially for 35 minutes, we need to keep it kind of short, hopefully you will learn something that you can apply this afternoon or tomorrow morning already in production. So let's see, and let's dive into the problem. I have a very simple application running at Xera WTF. If you wonder where that comes from, WTF is obviously the right domain for any demo. Let's hope it doesn't break today. Xera is my Twitter and GitHub handle, and I try to use it wherever I can. It's a ROT13 of my last name, which is Krenn. You rotate the letters by 13, you're at this. The nice thing about ROT13 is if you rotate by 13 again, you're back at the original because, well, 26 letters in the alphabet, so encryption and decryption is the same, just in case you were wondering. And what we have here is I have a login form. I will show you the form in a moment. I just want to show you the code first. We have really the hello world of code injections here. We have a select star from employees, where a name, and we just pass in the variable here and password SHA1. So we hash the password that we provide here. And then we don't escape this. We don't have a stored procedure. We don't have any other security mechanisms really around this. So this will be very insecure. But let's look at the form. Let's create a user, and then we can continue from there. So this is my application. And let's say we want to add another user. So right now I have Shai, our CEO, Simon, one of our co-founders, and me in the application. And we want to add another colleague or Elastic employee. So I need to log in, and my credentials are Philip, and my password is secret, which is not very secret, but good enough for here. And let's say we create another colleague. So I'll create my colleague Alex, who is based in Munich, who has a salary, and I don't know, he has a password. And I create this new user. So this worked fine. And maybe you don't have the right credentials and you still want to add somebody to Elastic, or maybe you want to add yourself to Elastic. Coming back to the hello world of SQL injections, how do we circumvent this now? So what you could do is you could just close the current command, say or true, and comment out the rest of the line. So what you would have here is then you would pass in here this or true, or maybe you would pass it in here. And then just comment out whatever comes after that. So we can very easily do that. Let me switch to my form again. So we close the name because we don't care. We say for true, and we comment out the rest of the line. We need to provide some password, but that will be commented out as well because this form field needs to be filled. But if I run that, even without having any user or credentials, I can just break into the form. And I can just say, I don't know, this is a wrong user who is coming from, let's say, hell. So we have our wrong user who has been created in our form here. So this was not great, but this was also very simple. Let's see if we can find other interesting pieces in this application. So we have done this. Let's have a look around, or let's discuss the problem in general. So yes, SQL injections are a thing and have been around for long. If you're coming from the newer world of GraphQL, some people might call SQL injections the accidental GraphQL because suddenly you have all the powers and you can run whatever commands you want. And I find this a very nice comparison for GraphQL, which is probably not entirely true, so don't complain too much about it. You have probably seen this table somewhere already. It's called Little Bobby Tables, where somebody named their kid, close whatever you're doing here, drop table student, and comment out the rest of the line. This is pretty similar to what I have tried to do. And we can, by the way, try this out as well later on and see what happens. So don't call your kids like that, or especially if you run any database systems, don't allow SQL injections which are susceptible to little Bobby tables. Otherwise, you will probably learn your lessons at the latest when your students try something like this. So don't be caught there. Another thing that might be interesting is if I look at some employee here. So you see we have Shy and it's here just being displayed, and I could go back. What is interesting is I just pass in the ID here, and this lists the user. So for example, if I had for user 2, this will switch to the next user. And once again, the code is probably not as good as it could be. Let's have a look at the actual code in VI. So that should be in var, www, HTML, and I think we have some read PHP. So what I'm doing here is, this is the command where I'm basically fetching the user. So you can see it's a select all from employees, where ID is whatever ID we provide in here. Again, no filtering, no escaping, no stored procedure or anything. What we do here, and by the way, we did that in the other form as well, we did log now the SQL statement. And this will come in very handy when we try to figure out what has been happening here afterwards. So we always log this SQL statement before running it, which might be generally a good idea if you run into any SQL injections, because then at least you can figure out what went wrong. And then I just run this command here. And just to keep it more interesting, I'm using MySQL multi-query. So this will not be able only to run a single query, but multiple queries. And why this is making a difference here, I'll show you in a moment. So what might we have or do here in our application to make a difference? So this looks interesting, but before I give you the final solution of how to break this, let's just take a look with SQL Map of how this looks like. So what we want to do is, or if you've never seen SQL Map is an automated tool that checks for SQL injections in databases and tries to take them over. Or it basically just scans and tries parameters and in various variations to see what might be possible in a specific form or variable that you pass on, and then we'll tell you, well, I found something that looks kind of suspicious here. And what you need to do is you need to run SQL Map against this URL, and then we just provide it with this ID here, and then SQL Map will try to run interesting parameters against this ID parameter. Also, I run it with purge since I have been running this before already, so we can actually clean this up, or it doesn't run into or reuse old experiments. I just want to show you a fresh data set. what I run is SQL Map -- URL, and then I also purge. And I think we should quote this. So this is SQL Map. It's running. It's starting up, and it starts running various parameters here. After some commands, it will actually figure out that this is running against MySQL. So here you can see when it's trying a sleep command against MySQL, this is taking a bit longer. And then it will tell you, well, I think this is MySQL, which is correct in this case. So yes, I only want to run tests for MySQL. And yes, I also want to run the riskier commands. So I don't have any production data, so I'm not going to destroy anything here. So we can just run this. At some point now, it will ask us, should it test any other parameters? No, nothing else will be vulnerable here, so we can just finish this test. And then it tells us, well, the backend database is MySQL, and this is running on an Nginx server, which is also correct. And then it found a couple of interesting things. So for example, it found out that it can run a union query and found multiple columns that it could access here, or that it could do a time-based blind SQL attack here. So what could we do with our data? I've already shown you the code here. What we could do now is we could just run a second command here. So we could again finish this one and just attach a second command because we're using this multi-query. So next to that select statement, we could just insert more users. Maybe something like this, where we add a bad actor, for example. So we're just adding a second after the semicolon SQL command after the first one, and just add our second one. Since you don't want to see me type this, I'll just copy and paste this. Otherwise, I'll just mistype and nobody will be happy here. So what I'm doing is I keep the previous command, I keep the ID, and then I just run the second parameter. And after running this, nothing seems to happen. But when I go back to the initial form, you see that the bad actor is here now. And he has been, since I only provided the name, the rest are default values. So everybody is from Earth and has a salary of 0. So that was pretty easy. Another interesting thing here, by the way, is we don't escape the output either. So once you add something bad here, that will be shown directly to you. This one is slightly longer. So what I'm doing here is I'm adding not just a simple string, but I'm adding a script with an alert, hello friend. So let's see when I run this and I go back, then you will have a pop-up every time you try to open this form, which is slightly annoying, but this is what we have just added. Because well, we just had a script tag here, so there is no actual string to display and just a pop-up that we have had or that we have just seen. So this is what I've done here. I just added a script and you could do whatever you want. You could even break the entire table if you have, or provide some HTML that cannot be rendered properly anymore, then you will break the entire page and nothing will work anymore. So not good, pretty broken application. But if you run some application like this and somebody starts breaking into it, you probably want to figure out what the heck has happened and what is the security issue and what do I need to fix. So you want to probably look at your logs, and ideally you have logs. Otherwise, yeah, it's not so great. One fear that some people have is that people break into your application. They might be able to delete your logs. You could circumvent it by not logging at all, but again, that's not really the solution. Like, you want to have logs to see what people have been trying here. And we basically want to log all the things, so as much as possible. And I only have these log statements for the SQL statements, but for my example, this will be exactly what I want. So how do I get those logs? Well, I could now SSH into the right server and then tail through the logs or grep through the logs. But that's probably not scalable if you have more than 2 or 3 servers. And if you have very large log files, this is also not going to be much fun. Like you will end up pretty much like this little submarine up here that's trying to find something in this bigger Titanic-like log file, and you don't find anything. And for that, you might be already using the infamous or famous ELK stack. So Elasticsearch to store your data, Logstash to get, parse, and enrich your data, and Kibana to visualize it. When I say parse, it's normally a regular expression trying to parse the different pieces out of one log line, like a timestamp, a log level, the message, maybe some other metadata that you have. And enrichment would be adding additional metadata to that on top of it. So if you have anything like, I don't know, you run in a specific container and you want to know the container ID, where this is running, or the version, you could add that, and then you could figure out, okay, this was this specific container version or container ID where we had the security issue. And today's stack actually looks more like this. So we have added this other component called beats, which is like a lightweight agent or shipper. So for log files, we have FileBeat, and that is pretty much like tailf, but over the network and on steroids. So it can just tail a log file, forward it to Elasticsearch to store it, and then Kibana can visualize it. Sometimes you want to have Logstash in here, sometimes you don't need it. For today, I will keep it simple. We won't have Logstash because FileBeat will just forward to logs. If we need to do any parsing, Elasticsearch can do some parsing as well, and then Kibana can just visualize what has been happening here. So before we get into this file, let's take a quick look what we actually have here. So going back to my application, what I have done here is, and this is really the simplest form of logging that you could use anywhere. I'm just logging out to var log app log. So let's take a very quick look at this file. Let's say less var log app log, and I jump to the end. And you can see this was the last SQL query in read PHP that I have been running. So this is just collecting all the SQL queries that we have been running. And you can see this was SQL Map that was trying some Aurora version, whatever query. So this was trying some whatever tricky queries. Whereas here you can see these were my injections where I was adding the bad actor or my hello friend pop-up. And now we obviously want to collect that and store that in Elasticsearch. So for that, let's take a quick look at FileBeat. And FileBeat can collect some standardized or default log files automatically. So basically here, those are the so-called modules where I say, well, take the Apache logs and take the MySQL logs and the Nginx logs and the system logs. So just collect those where we know this is the default location and standard format of them. And then they will be automatically picked up and parsed, and we can easily work with that. We could, if we have time, look at the Nginx access logs, for example, where you would see what is the response code, how long does it take, how much traffic do we generate, etc. And all of that could be put into a dashboard easily. But what is more interesting and what I want to focus on right now is that var log app log file that we have been generating. So what I'm saying here is I want to collect this log file, and I'm just putting that into or storing that with an extra field application.app. So this is how we will be able to find that. Since we are collecting lots of other log files as well, there will be quite a bit of information. Application app is how we'll be able to find it. And probably you should name your applications a bit better than app, but for a demo and a hello world, this will do. So let's head over to my browser and to Kibana. The classic way how you would approach this would have been to use Discover, but there's a better way to actually see your logs nowadays. And it's under this logo, and it's called Logs. So this already sounds promising. I think I should just make this slightly larger. So once my screen has loaded, let me make this slightly larger so we will actually see a bit more. So this is a stream of logs. This is pretty much what you were used to in tailf when you were just following a log file. This view is very similar to that. So here you can see this is just tail effing, and I can live stream. So this is really the tail F feeling. This will just show you what it is collecting, and you can see we have some Apache logs, and I could scroll up, and then you might see, okay, we have some MySQL logs, and yeah, got an error reading communication packets, so something is wrong with MySQL here, and we have another Apache access log. So we're collecting all kinds of pieces of information. But let's stop this, or let's actually filter down to the application that we're interested in here. So what I want to have here is application, and let me change my zoom level again. This is easier. So this will suggest all the fields that are available. So here I have application, and then I can just say equals, and then it will even suggest like what are the applications that, or which values are available for this application field. And app is exactly what we had in here. So when I filter down on that, and I can just, so here we have collected exactly the same thing that we have seen in that log file. And if I now open another view here, then the next statement, and it will appear in, I don't know, a couple of seconds, you will basically see what the application is doing here. So you will always have a fresh view of what your queries are looking like and what your users are doing. You could also use highlights, so you could only just look for read.php and just see, for example, which read PHP accesses we have had. And that's that. I just stopped the screaming because with Zoom running in the background, this seems to be struggling a little bit. So we'll just let this run like this. So this is where you can see what we have collected here. You could also open one of these entries here, and you can see we have not only collected the raw log message, but we have already also enriched that with some other meta information. So for example, I would know that this is this specific instance ID. This is running on AWS. So we could pinpoint the instance ID that might have been compromised by an attacker and then do something. Or you could see, for example, this is the IP address or the host ID. We could also see what operating system this is running. And all of those we could again include in our searches to actually filter down that we just want to see this specific kind of information. And this was the SQL query that we have been running before. So this looks reasonable. So we have found what our attackers have been up to here. What happens if I run a delete or drop? It won't work. Let's say we go back here. We head to this one, and then we say drop table employees. If I go back, the data is still there because I won't be able to sabotage my own demo. I have only allowed read and insert permissions on that user that I'm using to interact here with the database. So nobody can delete the data. So at least that I have done correctly, that I have limited the permissions of what I could run. However, in Kibana, I should still be able to find the SQL statement that I've just been running. So you can see these were the selects where I was accessing that data table. And now I already ran that drop table employees, which didn't work because I don't have the permission for that. Okay, so how can we protect against this? Maybe you have heard of ModSecurity. So what ModSecurity is, it's an open source project that is a web application firewall. So it runs in front of your application and can intercept the HTTP and HTTPS traffic, and then run some rules to filter out the bad stuff. And there are two rule sets that you can use. There is the free and open source core rule set, which has real-time blacklisting, and it can detect denial of service attacks. And it has a lot of rules built in to filter out attacks. There's also a commercial version that can do more things. And the two are kind of like separate and run by separate people, though they do share one GitHub organization. So these are the two things that you can run. I'm sticking to the free and open source version here, by the way. So I'm running Nginx on port 443 with HTTPS without ModSecurity, and I'm running Apache with ModSecurity on port 80. So if I run SQL Map against this, and I just need to change the port, this will behave differently because it's exactly the same application. I'm even using the same var www HTML folder, so it's really going against the same files. So it has exactly the same vulnerabilities, but on port 8080, it has ModSecurity running in front of it or as part of the application or application server. And this will actually block the request. So you can see the response here from SQL Map is already different because do we want to reduce the number of requests? No, we don't want to do that. So it will just keep running a lot of requests, but it doesn't find anything. Unlike before, when it could, when it did identify MySQL pretty quickly and then said like, well, I found all of these security issues. And what we have here is we see 126 times the request from SQL Map or got a response 403 forbidden. Why did we get all those forbidden? Because that is exactly what ModSecurity is doing. It's detecting potential attack, and then you can put it into different modes. So you could just monitor and log attacks, but I have put it into the more aggressive, like actually block mode. So any request that it deems an attack, it will just block and respond with a 403 response code. So just to show you how this behaves when I actually use it, when I had to port 8080, and the data is the same, but when I try to add a new employee, you remember what we had to do? So we were closing the previous command and said for true, and we commented out the rest of the line. When I run that, you just suddenly now run into a forbidden. And this is where ModSecurity is basically jumping in and says like, well, this doesn't look like a proper request. Let's block that. And SQL Map had exactly the same issue, looking more like it. So here you can see, and well, it's pretty hard to read, but this is one of the rules that blocked something. So if I open that one up here, here it says detected SQL injection using the fingerprint because, well, we used that. That was especially or exactly the command that I was trying to run. And this is one of the things that ModSecurity does detect. So this is what it actually filtered out and then rejected my entire request. We could run or show this on an error dashboard now as well, and then we would see all the response codes that we had and the actual errors, but let's skip that for today. We don't have enough time. What I want to point out is in ModSecurity, so it has a configuration file, and there you can turn the rule on, detect only or off. I have it in the on mode. For your production setup, it is probably highly advisable to put it into detection only mode, then go through your logs, see what it would block, and only if it does block actual attacks and not legitimate uses, I would turn this on. Otherwise, you might enrage your users by blocking their proper requests. And you can also limit things like how big can the body of a post be, for example, or how big can an upload be. So things like that, just to protect your application against a denial of service attack, for example. All of that is easily possible with ModSecurity. What is very important for the log part is that you actually specify that this should be output as JSON. It doesn't really look like JSON here, so that the actual field is very hard to read, but you can see audit handler application came from here, audit engine, the operator, etc. All of that was actually spat out in JSON from ModSecurity. Otherwise, you would need to parse that by hand with a regular expression, and that's normally not that much fun. Whenever I ask like who likes writing regular expression, a couple of people raise their hands, and then my answer will normally be that this is like the Stockholm syndrome, where you get so used to doing something that at some point you accept that this is the right way to do. But I'm lazy. I don't want to write my own regular expressions. So probably you should not either. Okay. You can also add custom rules in ModSecurity. And this is actually an interesting one or a fun one. What I'm doing here is on the create PHP form, if somebody tries to post a body which contains shy or ban on our founder. So basically, if somebody tries to create a fake shy, then I want to block that request. In reality, probably, especially if you cannot change your application, you would put in something like here that filters out Rolex or Viagra or whatever spammers might be using. So this could be a very easy way to actually add spam rules on the fly without changing your application. And ModSecurity can just filter that out from any request and reject the bad request. But let's try to add a fake shy. So what I want to do is I want to reload that login form. I know my correct login, that was secret to log in. And then I want to say there is another shy, but I need to spell his name correctly. Let's say he is still based in Amsterdam, where shy used to live in the past. Let's create this and put the password. And when we do this, again, we get a forbidden back because the wrong shy or the fake shy was filtered out. Just looks like this. And then shy is even smiling when you filter out the fake shy. So what the result would look like is it would say like access denied with a 403 because we matched this shy ban request in here. And as you saw, it was actually really filtered out. Did it already appear? Come on, live stream. Find my fake shy. Okay, it's shy right now, but it will appear in a couple of moments or so. Or we could just highlight shy because I think I've tried that out before. And that should find the fake shy as well. Or maybe not. Where is my fake shy? Okay, you'll have to believe me. You will be able to find the fake shy in here. Probably a browser refresh would fix it. My browser seems to be sluggish today. However, one final note here is ModSecurity is not foolproof. There are ways to circumvent it. So for example, if you try to use the login form and you use parentheses in the right combination, this will pass through ModSecurity. So just to show you, and I will copy that so I won't mistype this one. So if I copy this one, I will cancel that request. Hello friend, I will log in, and okay, since I still haven't created a proper user, I still need to create the proper user once because only afterwards I will be logged out. Let me log in now. So if I use this one here, this one passes through ModSecurity, unfortunately, which is slightly unfortunate, but yeah, the rules need to be updated again. So yeah, everything is on fire and terrible. So to wrap up, security incidents normally come in 3 levels. It's like for your information, which you mostly ignore. The WTF is like probably something you want to fix, and the oh my god is stuff that you definitely want to fix immediately. Ideally, you fix the security issues in your application. If you cannot do that, especially if it's external applications, ModSecurity will still give you extra buffer and is maybe a good protection for your own applications as well. As a takeaway, write better code than me and my demo. and use the proper libraries and frameworks, especially around injections, because there is good tooling out there to actually make your life easier. The question I get quite frequently is anybody using this? Well, quite a few. One common use case where, for example, ModSecurity is pretty widely used by now is in GitLab. They have added that as an ingress in their Kubernetes deployment. So this is one of the many places where, for example, ModSecurity is being widely used. For logging around security, our stack is also pretty widely used, from Slack to Mozilla to Cisco. And we have a couple of other applications and use cases in the security space by now as well. So generally, ModSecurity and logging go very well together, and one won't make so much sense without the other. So even if you block out lots of stuff, you still need that centralized logging to see, like, do I block any legitimate requests? And also, what bad stuff am I blocking out? And do I need to fix anything in my application? So there, it would make a lot of sense to actually have that. If you want to try out all of that yourself, here is the code. So just copy that and go out. Slides are available under this QR code, so I'll let you take a picture of that. With this, I guess we can just jump to questions. Thanks a lot for joining.
Okay, great talk, Philipp.
Thank you so much.
I think one of the common themes we've been seeing across this event is that I guess no security is foolproof. I liked how Sarah Young put it. That's out of scope, said no attacker ever. So yeah, you have quite a few questions in the feed. So let's go right ahead. So what's the overhead of the file beat agent?
The file beat. So the answer that we will always give to that is it depends, because it depends on how many files and folders will you monitor, how much data are you shipping off. But generally, it should be pretty low, like not so much I/O. If you're on Linux, it's probably still in a file buffer. So you're basically handing over whatever you had in memory to the network interface and just ship that off. And since we don't do any parsing on the host there, this should be very minimal. And like in terms of network, depending on how much data you want to transfer, CPU and memory should be pretty minimal. So it's a Go binary, really minimal. I wouldn't worry about that.
Okay. And I guess without being biased, right? And it's going to be kind of a tough question for you to answer, but what are the advantages / disadvantages that you see in comparing Elk Stack to other log management products like Humio or Splunk? I'll enable you to.
Yeah. What kind of answer do you expect now? But in all fairness, I don't know Splunk or other products that well. They all have kind of like their sweet spots. I think Splunk is kind of well established from a long time ago, if you have the right amount of money. Other approaches are very cloud heavy and cloud focused. I think our approach is very much that we are trying to bring the solution to wherever you are. So we have the cloud service, you can run it on premise. It's just up to you. And we build on this speed and relevancy paradigm, because what people often forget is in the logs, you're not interested in storing the logs, but you're interested in quickly retrieving the relevant parts. So this is where we come from. I'm definitely not the right person to give you the comparison, I think. And I won't try, because this will not be fair and I would just misrepresent the other products. So I would kind of dodge that question.
Okay. So if you just had to give a couple of, I guess, in a couple of tips, what would be your best practices when it comes to log management that are in ModSecurity?
So best practices for log management. The number one thing that I see that makes people's lives much harder than it needs to be is that you have like your application knows what you have in your log, and then you log out that log line, and then you write a regular expression to parse it back. And then people complain, this is a lot of work and this is overhead. And yes, you're right. This is overhead for the computer to actually parse it, because regular expressions are not always that performant. And the plural of regex is regret, so don't do that. You should rather have a structured format. And ideally, especially for our case, would be JSON. So if you log to JSON right away, you can just tail the JSON, put it into Elasticsearch, and you're done. And we have this schema format. We call it Elastic Common Schema. If you stick to that, you're really done, and you can easily correlate different log types together. We have like the right log libraries for different programming languages, and our products will try to produce that log format. And it will really make your life a lot easier. And you don't have to struggle with writing regular expressions and mapping different kind of formats to each other and fiddling with dates and whatever. Just don't do that. Be lazy like me and just use the libraries to do that, and use a structured format. Unless you want job security and you want to write your regular expressions that nobody else can debug anymore. That might be the only excuse, I think.
Okay. Anything else you want to share with our viewers?
Nope. Thanks a lot for joining. If you have any questions, just ping me on Twitter. By the way, the instance is still live and running. So if you go to Xera WTF, you can just try it out yourself live if you can break in or not. So if you're bored this afternoon or morning or whatever your time is, go wild. I'll probably take it down tomorrow, so it doesn't end up like a spam host or anything. But if you want to have a play, enjoy your evening.
Super cool. The guys for the demo were good too, although it was pre-recorded, but it looked like it was working in real time too. So that's very cool. Thank you, Philipp, for being with us. Great having you.
Thanks a lot for having me.
Feel free to check out the platform and interact with the folks. There's some people asking more questions, so feel free to interact.
I'll jump over there. Bye.